All right. So I guess I'm starting today with Houston here, guest starring. All right. So let's go ahead and recap what we've done so far with this development process. So the first stream that I did, I managed to get the data path mostly assembled and mostly working, but I didn't have time to take a crack at the proper network device driver at all. Today, so yesterday I picked up where I left off, and I did most of the work on the driver to get some signs of life out of the hardware. But unfortunately, I didn't have quite enough time. I had a hard stop to actually get the everything fully connected and to get ping working through this thing. So what I'm going to do today is pick up where I left off, and we'll see what we can accomplish here. I think I'm like 99% of the way there. There's only a last little, problem or two that has to be sorted out before ping will work. Now, there are probably some other bugs that would have to be sorted out to actually make something that's even reasonably possible for, production. But, yeah. The first, well, probably the biggest issue that I ran into almost immediately is that, I forgot to disable the queues when the driver was unloaded, and this resulted in causing some corruption in kernel memory. So yeah, this triggered a null pointer dereference. Not sure exactly what the code path was for this thing. I don't think this initiated in the driver, but it was definitely related to the kernel or the NIC DMA engine going and writing over stuff it wasn't supposed to. So we're going to fix that first, and that one I think is pretty simple, right? So in the create net device code here, we set up all of this stuff, including enabling all of the queues and configuring all the region addresses and whatnot. But when we take the thing down, we don't really do any proper cleanup of the hardware. So what I'm going to do here is very simple. I'm going to take all of these lines, which disable the queues, and I'm just going to duplicate them down here. So that'll be the first thing that we do during teardown, is we just disable the NIC, basically. I got a question here. Wanted to ask if a complete beginner following this series and building a NIC. Well, I didn't really intend this for complete beginners. And I'm using a lot of existing library components. So you probably have to do quite a bit of background reading and research and whatnot to get familiar with all of the basic components and whatnot. But if you have a sufficiently high level of knowledge, then you should be able to follow this and make a NIC, hopefully. I mean, this wasn't really intended to be like a super instructional stream, but, and also the NIC that I'm putting together here is like, it's extremely stripped down, extremely simplified. So, but it's at least a starting point. And yeah, I mean, if it's something that I can put together in, well, let's see. I guess this is about 2 days and change worth of work, right? So, that's probably a reasonably good sort of introductory level project. What kind of prerequisites? Well, I mean, you got to be reasonably familiar with digital design generally. So that's a good starting point anyway. And general system Verilog syntax, and I'm using CocoaTV for simulation, so some familiarity with how CocoaTV works. Or I guess you could do it in some other environment if you wanted to, but yeah. I'm not going too much into the background here. Anyway, let me get back to the code here. So I've gone ahead and I've added this teardown code. So what I'm going to do now is we're going to see what happens if I run that. And again, the plan is to get to a point where we can run ping on this thing. So let me go ahead and get the message up here. I think there's another issue that I'm going to have to debug at some point, and that is an issue with how the pointers are wrapping around at the end of the allocated block of descriptors. So I just need to make sure that I unload the driver before it wraps around, otherwise it's potentially going to overrun the end of the buffer and cause trouble. Yeah, so one step at a time here. I have the message, right? And what else do I need? I need, all right, so here's for loading the module here. I'll build it. All right, so this is iperf, or not iperf, this is TCP dump running locally. So this is the link partner that the NIC design is connected to. I should have another window around here somewhere. Where did it go? That one. All right, where? I got too much stuff open right now. Okay, so this one I was going to use for pinging. So yeah, so if I hit that, we can see that it's sending ICMP echo requests. That's interesting. I was expecting ARP requests. Okay, there we go. Now we're seeing some ARP requests. Okay. Where was the other window I had open? I thought I had something with iperf on. Did I close it? That's annoying. All right, I guess. Or maybe I was just running it here. I was just running it here. All right. Trying to remember the setup that I had last time. All right, so here's what we're going to do. I have the dmessage output here, so we see all the kernel output, right? This is the output of TCP dump on the link partner device. And then I'm going to run iperf down here in a minute. And then I also have, wherever I put that, right, so ping. So I'm going to go ahead and start that so we have some packets flowing along here. And you can see this is sending ARP requests. So right now there's no responses or anything, but yeah. And this is also running in a network namespace, so there's nothing else on here generating traffic. So the only packets we're going to be seeing on the receive path here are whatever, you know, ping is sending directly or triggering. So ARP, that's not coming from ping obviously, but that's coming from the operating system as a result of ARP trying, or ping trying to send packets. All right. So let me go ahead and we're going to install the module. Okay, so if I install the module, let me also start up, I need to do two more things. Let me add an IP address here, and let me also start TCP dump. All right. Okay, so we can tell that there's some stuff going on here, and we can see that we're seeing the ARP requests coming in, and we're actually seeing ARP replies going out. It hasn't crashed yet, so that's good. But we're not seeing any ARP replies over here, right? We're just seeing the ARP requests going out. So I guess that's progress, right? It isn't crashing. Let me also try just an unload and reload just to make sure that things seem to be working correctly. So I'll unload it. Okay, that looks reasonable. Didn't crash. Reload it, and it's running again. Okay, but you know, same thing. We're still not seeing ping working, right? And we're not seeing the ARP responses. We're only seeing the requests go out. So question is, where is the problem here, right? Is this an issue in the hardware, or is this an issue in the software, right? If I messed something up in the driver. You always hope that the issue is in the software because it's going to be easier to fix, but you have to be able to, you know, narrow it down and figure out exactly what's going on. So let me just stop both of these TCP dump traces for a second here so we can take a closer look and see if we can figure out what might be going on. So in this particular case, let's take a look, see if we can map these traces, the iperf output, not iperf, why do I keep saying iperf? The TCP dump output versus the information from the driver. So let's see, the last few things that we got were just a bunch of ARP requests. So we saw ARP request. Let's see, how many do we have here? 1, 2, 3, 4, 5, 6, 7. 7 of these. Yeah. And I think we see all 7 over here, right? Well, I don't know when exactly I cut this off, but 1, 2, 3, 4, 5, 6, 7. Yeah, so we see 7 over here as well. And we see both the request and the response. Now, you'll notice that the lengths are different. And this is because at some point along the line, I'm not sure exactly where it happens normally, but the frames have to get padded out to a minimum length. So in this case, these are nominally the same packet, but this 46-byte one has a bunch of extra zeros added at the end of it to get it to the minimum length. But we don't see that here. So in this case, since this one is coming from the workstation computer to the NIC, or to our NIC design under test, this has been zero padded either by the kernel or by the transmitting NIC. In this case, this will need to be zero padded somewhere to minimum length, either, again, by the operating system, by the driver, or by the hardware. The way I should have things set up is to where the driver pads it out to the minimum length. But I think we noticed some odd discrepancy that I couldn't explain about the length, which is potentially suspicious here. Anyway, let's take a look at the kernel driver output and see if we can, correlate these things. So we are seeing like packets here. So here's the interesting part, right? This packet, let's check on the address here, right? So we can see this ARP reply, that's the source MAC of this, and the DHCP request, right, that has the same source MAC. So these are being sent by the same device, right, by the NIC that we're trying to get operational here. We see the DHCP request here, right? That's the same MAC address, but we don't see the ARP replies. So that's really perplexing. So that is indicating to me that the receive path seems to be working because we can get packets from here into the, through the NIC design into the kernel, and then we're at least getting some things in the other direction, right? Because we are seeing this packet here, which has come from the kernel on this end, that's feeding through the driver that we wrote, through the NIC design, going out on the wire and showing up here. But for some reason, we're not seeing the ARP replies. And those seem to be the only packets that are missing. That's a bit of a head scratcher. All right, well, let's take a quick look at this and see if we can correlate what's going on here. So we have a bunch of write descriptor. This is, right, so we get a packet for TX and then we write the descriptor into the queue. So there's 1, 2, 3, 4, 5, 6, 7, 8. So far anyway, right? Okay, write descriptor. Oh, there's another one, 9, 10. Okay, here's one length 325. Right, so this length 325 looks to be, this says 283. 544. I'm not exactly sure what this length is indicating. If this is like the IP payload length or something, then this might actually be correct here, right, with the 325 correlating with this. I think if you take hex 140, 1, 2, 3, 4, 5, hex 145, I think that's 325. So I think this packet matches up just based on the length. So we're definitely seeing that one go out. And then we have a packet coming in for receive. I don't print out the length for that. And then there's a packet for TX length 42. And we see a bunch of those, right? 1, 2, 3, 4, it's like 10 of these or something. But none of them seem to get sent. So it's making me wonder if there might be a problem like with the Mac and it's not actually padding things correctly. If it was padding things incorrectly, then what might be happening is that even though this is set to promiscuous mode and the operating system's not dropping anything, it's possible that the the NIC is dropping those short frames first, or they're getting dropped somewhere else for being smaller than the minimum length because they were padded incorrectly. So probably the proper solution is to figure out why that Mac is not padding things correctly. And that's actually really perplexing, because I've used, I guess maybe not so much the 32-bit design, that's relatively new, but the 64-bit design has been in use for a long time, and as far as I can tell, that pads things correctly. And it seems to work correctly in simulation, so I need to dig into that and figure out what exactly is going on there. But in the short term, what we can do is adjust the device driver and basically manually pad the packets out to the minimum length. And then we'll see what that does. So the question is, how do we do that? I'm actually not sure the proper mechanism for padding out a frame to the minimum length. We will need to pad it. Where is this? Yeah, okay, so start transmit. We'll have to pad it in here somewhere. I have a check. I thought I had a check. Right, here's a check for dropping short frames. If there's a really short frame, it drops it. But for larger frames, then we should ensure that it gets padded out to minimum length. So I did some poking around, and I looked up this this API call here. So if skb put pad to KB, and then the minimum length is going to be 60. And then if this could potentially fail. So if it fails, then we go to tx drop to drop the frame. Yeah, so tx drop will free it and return. So we're going to try that, and we're going to see what happens. I think I'm not 100% sure about this, because when looking at the documentation for the SKB code that I could find, it seems like there's like 4 or 5 different functions for padding, and it wasn't exactly clear what the difference is between them. There's like there's skb pad, there's skb pad 2, there's skb put pad 2. So we're going to try this, and we're going to see what happens. All right, so I put that in. Let me go ahead and rsync that. All right, and then let me pull up all these windows again. All right, so ping is still running. Let me go ahead and build the driver. Oops. Happened. Okay. Why is this? All right, this is. It's always something. All right, this terminal window seems to be hung or something. I don't know what's going on with that. All right, let me try this again. All right, let's build that, and then I will go ahead and insmod it. Okay, and then I also need to add the IP address, right? Hang on, let me go copy that here. Even if this terminal is not working, I think I can still copy stuff, right? Okay, there we go. Copy that and paste that here, and oh, well, there you go. Ping is working now. So that is exactly what I was hoping to accomplish here. And if we pull up TCP dump again, we can see both the request going out and the response coming back. So there we go. All that work yesterday, all that head scratching over why it wasn't working, and it was just some sort of hardware issue on the relating to the Mac. So I'm gonna have to dig into that and see if I can figure out what's going on there. So there you go. And I'm gonna have to unload this driver before it loops. So I also need to take a look at that. I think I did something wrong with the way I was masking stuff off, or I don't know. I need to take a look at that. There's several possibilities. But yeah, okay. This seems to be doing what it's supposed to do. It's actually pinging, so we have communication in both directions. Oops. was working for a while, now it seems to have stopped. Uh-oh. What happened? Oh. Network manager. Yeah. It removed the IP. Okay, now it's running again after re-adding it. Well, I got 2 pings. It removed it again. Great. Yeah, this is one of the reasons to use network namespaces, is it prevents other stuff from messing with the interface. So, yeah. I think this is successful. And like I said, this was going to be a short stream today because the idea is, you know, if this thing is basically done, it's just a question of doing a little bit of debugging. Then yeah, I think that polishes that off. I'm going to probably spend a little bit of time doing a little bit of cleanup and see if I can figure out this, you know, the Mac padding issue. That's a high priority thing to figure out. And then also the descriptor wraparound thing. In fact, I'm going to go unload the driver here before this crashes. Let me see here. All right. And I guess we could take a look at that wraparound thing and see if I can figure out what might have happened. Just a quick peek here. So this is going to apply to the completion read and descriptor write code here, where we are doing this masking operation here. So we do the RxQ size 16 minus that. We generate a bit mask. Then we AND that with the pointer. And all of these should be set to the same value. Let me take a look actually at the waveform and see what exactly is being set in some of these signals. So if I pull up the, where is this here? Completion write. Yep. The size signals are, yeah, it's set to 8. RxCQ size and TXCQ size, they're both set to 8. So I think that should be right. So that would be 16 minus 8 would be 8. We shift by 8. That should have 8 bits set, so that should limit the number of descriptors in the ring to 256. You get 256 times 16. I mean, it seems right to me. I guess what I can do actually, let me think about this for a second here. Sometimes you got to start getting a bit creative when diagnosing some of these things. Like if you're going to put 256 entries in the queue, that could take a little bit of time. But the other thing we can do is we can just make the queues a lot smaller. So instead of setting these, actually I guess what I'm going to do is set these to 0 by default here. And then I will set these to, oops. What did I do? Okay, so all right, so that was correct, and then this one, yeah, there's a different number of lines here, so that that didn't work the way I was expecting. All right, so let me make this a lot smaller. How about I make this like 4 entries? Where did the simulation go? I had that up at some point. Oh, here it is. All right, so let's go ahead and rerun that. That's going to make the queues a lot smaller. Then I'm going to enqueue multiple transmit packets, and we'll see what happens. All right, so at this point, I'm going to go ahead and do this procedure again. I'm just going to enqueue the same transmit buffer multiple times. All right, so the descriptor. All right. Also, I need to manage the wraparound here. Okay, so this is fine. So I'll do 1. Increment it. Yeah, I don't need to do the hex dump at this point here. All right, so I'll do 1. I'll do 2. I'll do 3, and then I'll wrap back around to 0. I think that should work, right? Okay. Alright, so let's run that, and let's take a look at the waveform dump and see if this wraps around correctly, or if there's something else weird going on. Oh, I also need to wait for stuff to happen. Otherwise, this is not really very helpful, is it? Alright, try that again. I'll wait a bit longer here just to make sure we got plenty of time to transfer these packets out. Okay, so that was interesting. So what happened here? So I've gone ahead and incremented this 2, 3, 4, 5. Wait, 2, 3, 4, 5. Oh, right, yeah, because I had it set to 1 initially. Yeah, okay. So that should cause it to wrap around. Okay, that makes sense. But this did not do the correct thing. So, alright, there's definitely some issues that need to be sorted out here then. That's interesting. Alright, so we got 1, 2, 3 packets. But why are these packets coming through with the wrong length? Hey. Yeah, just classic. This is not necessarily working out how I was hoping here. Oh. Yeah, that would make a big difference here. I actually need to multiply these. So this is going to be, instead of writing it to say 0, this would be 16 times 0. And this one is also 16 times 0. And then these are going to be the same thing, right? All of these need to be 16 times whatever. Alright. Let's see what that does. Yeah, so in that case, it's just reading all zeros. Although, why did it generate such a big block if it read a 0 for the length? I don't know. I'll have to look into that. Alright, let me take a look now at the waveform dump. Alright, so let me see exactly what happened here. So we have the pointer incrementing. That is expected. That's correct. And now the question is, what index did it end up using in the table? So let me take a look at the descriptor read logic here, and we are looking at the basically the read descriptor source address. Oh, I'm looking at completion right. Well, doesn't make that much difference. You can see the size set to 2. So that's correct. Okay, so this actually does seem to be working, right? It goes 2010, 2020, 2030, and then back to 2000. So that actually does seem to be working correctly. Interesting. Yeah, I guess I will have to debug. So I was seeing some strange behavior before where when it wrapped around, it didn't seem to be doing the correct thing. Basically, it stopped handling the completions. So my original thought is that it wasn't wrapping around correctly, but the other possibility is that I messed up something somewhere in relation to the phase tag. So anyway, I don't want to waste too much time right now debugging this. The main thing I wanted to accomplish was getting ping working, and that was successful. So at this point, I think I'm going to go ahead and close down the stream for now. If you guys have any questions or comments, you're welcome to go ask about it on the Corundum Zulip. I guess we'll see if I do more of these just pure development streams. I think it's more interesting to do something that's more like a presentation or experiment kind of thing. So next time I have one of those, I'll hop on and do it. So yeah, for now I'm going to go ahead and sign off, and we managed to get this thing working over the past couple days, which is great. And this will be a basis for, you know, the next generation version of Corundum, both Corundum Micro and Corundum Lite. So yeah, thank you very much for tuning in, and I'll see you guys later.